All right, so we're asked to solve this linear/quadratic system graphically. But the problem is our calculators. I mean, obviously you could graph this by hand, but when you take the SAT, you have to do it quickly. So in order to do that, I got to solve for y. So I'm going to say y plus 3x equals 0. To solve for y, I'm just going to subtract 3x from both sides. When I do that, I get y equals negative 3x. Now, if you're not sure, and I always remind students of this, I'm going through and showing you the steps of what to do to get y by itself. If you do not know why I subtracted 3x, and you do not always know how to solve an equation, you need to ask questions, okay? But the short version of it is I'm going to do the inverse operation. So let's try this other one. So if I say y minus 6 is equal to negative 3x squared, in order for me to graph this on our graphing calculator, I need to get y by itself. The positive, well, let me back up. This 6 is what I need to move away from the y. So because I want to move this negative 6 away, I do the inverse operation. In other words, we're subtracting 6. The inverse of subtraction is adding. Also, whatever I do on one side of the equation, I have to do on the other. That leaves me with y, because negative 6 plus 6 equals 0. 0 plus y is y. Over here, I've got 3x squared plus 6, because they're not like terms. So the common mistakes when solving an equation is somebody just does the wrong thing. You can't just make this up. Okay, there are very set rules. If you don't know the rules, come and see me during Mustang Family, and I'll explain them to you. Okay, but I think that's probably the most common mistake when it comes to doing these. Somebody will subtract something when they're supposed to multiply, or they do the wrong thing, and then that it's wrong, unfortunately. So now what I want to do is I want to plug those into my graphing calculator. So in y1, I'm going to plug in negative 3x. And then for y2, what was it? 3x, negative 3x squared plus 6. Okay? Is that right? Yeah, plus 6. And so when I hit graph, notice that it intersects in two spots. All right? So that's a good thing. We should have two solutions because we have a second-degree polynomial in our quadratic. Now, there's two ways to do it. It looks like negative 1 and 2. So if I hit second graph, that takes me to the table. All right? And I said when x equals negative 1, they equal each other, right? Well, yeah. Look at this. When x equals negative 1, the first equation equals 3, and the second equation equals 3. So x equals negative 1 is the first solution. Then I said possibly at 2. In other words, when x equals 2, notice that y1 equals negative 6, and y2 also equals negative 6. Now, those are the only two intersections. So, our solutions for that, x equals negative 1 and x equals positive 2. And that's it. Now, if you want to plug those numbers in, you'll see that you'll get a positive 3 when you use negative 1 in both scenarios, and you'll get a negative 6 when you plug in positive 2. Let's do the next one. So, same thing here. If I say y plus 1 is equal to 1/2 times the quantity x minus 3 squared. I just want to add, not add. What's the opposite of adding 1? Yeah, subtracting. So I'm just going to subtract 1. Now here's a nifty little trick. We're not being asked to solve anything. We're just being asked to graph. So we could actually leave it like this and graph it. All right, let's do the next one. I've got x minus y. This is one that students will make a lot of mistakes on. I want to get y by itself. Let's take a guess. What do you guys think we need to do to move the x away? Here's a common mistake. You have four choices. I could multiply by x. If I multiply by x, what's going to happen to this x over here? I get x squared. I could divide by x. If I take x and divide it by x, what does it equal? 1. X divided by x equals 1. Does that get rid of it? No. I could add x to it. If I add x to x, what do I get? 2x. What happens when I subtract x? I get 0, right? Saw some students do this. So that gets rid of it. Remember, whatever I do on one side, I got to do to the other. So sometimes what students will do is they'll say, oh, I just divide by x, and they write it down, and they don't think about the math. So if you're not sure, go through those 4 scenarios. It literally took me 15 seconds. Okay? But x minus x is 0, so over here, I'll do this side. That means I have minus x plus, that's a positive 6, so I'm going to say plus 6. They're not like terms, so I just add them up. All right? What do I put on the left-hand side? Huh? Yeah, negative y. Or you could say 0 minus y. But that negative sign does not go away. Good. Some students forget it. Changes the whole answer. So now how do I get rid of this negative? Huh? Well, that's just negative 2. Yeah, how do I make, let's assume this is a negative 1. How do I make that equal positive 1? How do you make a negative 1 equal a positive 1? Yeah, you got to have a negative. So what you could do is there's 2 ways. I could divide by negative 1, or I could multiply by negative 1. So if I take this term and I multiply by negative 1, remember I got to do that over here. Now the beauty of multiplying by negative 1 is it just changes the sign, right? So negative 1 times negative 1 is a positive 1. Positive 1 times y is just y. What's negative times negative? Positive. So negative 1 times negative x just becomes a positive x. What's negative 1 times positive 6? Negative 6. So those are my 2 equations. Now we just have to graph these real quick. Whoop, that's a big graph. Let me see if I can move this over to the side. How did I got to remember how to do that. I don't want the big one. Yeah, we'll do it like this. So if I go into y equals, clear this out, and I put x minus 6, and then I come down here and I put math for fraction, go over to the fraction thing, and I hit 1 and 2. I should have cleared that out first. Let me clear all this out. There we go. 1/2 times x minus 3 squared, and then I'm going to subtract 1, right? So I'm just plugging that in exactly how I have it written on the board. And I hit graph. Now what do you notice? Yeah. Yeah, I can. Yes. Oh, remember to get a fraction, you go, here, I'll show you on a different screen. Okay. You hit math, Then you hit the cursor all the way to the right, and you choose ND. You're welcome. Okay. But anyways, when you graph it, what did we say the solutions were? The solutions are where they intersected, right? Because when you solve a system, you're looking for what values of x will give you the same y for both equations. Yes? You got something way different. You put a negative sign in front of your quadratic. So what's the intersection for this thing? Yeah, it doesn't have one. So if it doesn't have a quadratic, what do we do? Huh? What do you think that means? Yeah, it's no solutions, right? It means there are no solutions. So we say no solution. Now before what do you want me to do? Yeah, I'll zoom out so you can see the whole thing. Any questions?